But apparently there's another stretch of wind coming.
Coming.
But I think most of it is now done.
Okay.
Apparently there's another. Good morning, Marcella.
Hello.
We're entering the matrix. There's a meeting inside this meeting.
Who is
Exactly.
it's Thomas. Thomas. Okay, I see.
Thomas and Michelle. Morning. And
Yeah.
Anna.
Hello, Chris.
Hello.
Always funny to see my old desk perspective when Chris.
Yeah, so
Makes me a bit sentimental. Okay. It is 9:30, so let's make a start. Today we do not have a paper. It's quite exciting.
Nope.
Today we have a data analysis environment for reproducible neuroimaging called Neurodesk. And Evie is gonna show us why we should know about it and what we can do with it. And I'm just gonna reshare the link so everyone has it.
yeah.
Great. Evie, if you want to take it away.
Yes. So, hi everybody. So today, I will not focus on a paper. In fact, when I checked, when I told Steffi I was doing this Neurodesk thing, I just noticed there is a paper about it. So I can share the link too. Here, like that. You have the paper. It was published this year, the first week of January in Nature Methods, and it's a brief communication. So yes, I want to talk about the Neurodesk platform. So it will be geeky Neuroccino because I want to do kind of tutorials of on how to use it. So this Neurodesk platform was developed in Australia in the University of Queensland by a guy, by a team and a guy, Stefan Bollman, and his team. It was presented in OHBM 2020, I think, and as I told you, there is a paper just this year. So I'm just citing the paper that Neurodesk has been developed as a research tool to facilitate the analysis of neuroimaging data. So it's a platform, it's a neuroimaging tool. So the focus is designed to help researcher in the neuroimaging field. And so they want the main purpose is reproducibility of the neuroimaging studies, and they want the thing as any kind of open science framework. They want the data to be accessible and reusable. The same thing for the codes. They want people to be able to access it and to reuse it. And the main point of Neurodesk is to have the access to the same softwares and to be able to reuse them. So when I say softwares, they talk about the same computing environment, the same version of the software, because we know if we do analysis with even the same software, if you don't take care of the version you are using, you can have different results. So they want to bring a solution to that. So that point complies with the FAIR principle. Let me share the screen okay, yes. Share. So for those who don't know the FAIR principle, it's a guideline for any kind of research materials where you want these materials to be findable, so you can find them. This is the first thing. You want them to be accessible so open access will be the best. You want them to be interoperable. You can move to an environment to another. And the main point of reproducibility is to be able to reuse to the data or the softwares to be reusable. So the main project, Neurodesk, complies with this guideline of FAIR. So in the paper, they emphasize that they want to bring a solution for neuroimaging analysis to be accessible. They emphasize accessibility, flexibility. They want people to be able to move to a software to another without the cumbersome to install softwares. Accessible, that was the main point, the first point, that they want people to be able to access the software easily. Portability, they want people to be able to move to one computer to another. And reproducibility, so that means they want the researcher to be able to reproduce their neuroimaging analysis. So that is the global framework. So now we can jump in the Neurodesk environment. So you have the link. So if you click on it, you have this page. And as you can see, so this is a web page where, so Neurodesk is mainly containers. So for those who don't know containers, it's a computer in a box. Let's say it like that. Or if people knows virtual machine. So everything is in this box. And one quality of that is that you don't have dependency issues. So as you can see, you can run it on your local PC. You can run it on high performance clusters in the cloud, in Google Colab. As I said, they want it to be flexible, so you can use on Linux, Mac, Windows, and you can have different type of interfaces and different type of processors. But one cool thing about it, you can already play it in your browser. So I will, before to go deeper, I want you to click on the play button. That brings you to this page where you select the closest region where you are. Smile in a minute. Okay, so let's select this one. So now it's running. It will take a few minutes to run. So normally I should have said before, but okay. Now, so as I said, it's a container, and everything will be in this container. So it's specifically designed to contain all the softwares you need to run neuroimaging analysis. So it's running. So as I said, yeah, you can download it on your computer and install it on your computer, but and the portability is cool because if you want to run a lot of analysis, you can also move this container in high performance clusters where you can run parallel jobs at the same time. So that is really cool. Okay, so it finished. So now you should get this page. And you just have to click on New Desktop here. And it should open a new tab, hopefully. And here you have two choices. It doesn't matter the one you choose. You can select the one you prefer. Let's go with that. And here you have your Neurodesk. So it's a computer. You have so it's a Linux computer. So here you have the menu, you have a terminal. Let's click on it. Yes, you have a terminal. It's so as I said, so if you go there, there is a menu here, Neurodesk, and you have any kind of neuroimaging softwares you want to use. You have, for example, diffusion imaging, you have FSL, you have Matrix, diffusion toolkit, you can do some image segmentation with SPM or any kind of or Cat12 also, free surfer, and everything is working. So you just have to click on the things. And you have different versions. So for reproducibility is good because you have everything in the box and you know the version you are using. If you keep the box, you can reuse it later. So everything is running. So the way it works, a little bit like in our lab, you want FSL, you type FSL, you have it. And if you want to open FSLize, you open it like that, it should open. Okay. So that is good. So if you want data in it, what you can do, for example, I want to run also a demo on that. So what I wanted to say. So yeah, one point I want to say before we go on. So this version of Neurodesk is what they call Neurodesk Play. It's a temporary session, so you cannot keep it a long term. But if you go to another kind of Neurodesk, you can keep it. Or if you install it on your local PC, you can keep it too. It has on the web browser, it has limited resources. You cannot do big analysis, but at least you have way of doing analysis. So the way I encountered this tool, that it's when I discussed with colleagues and collaborators, I saw two different use possible. The first one is you are somewhere with your personal computer, but you don't have softwares on it, or you don't use, you have a Windows and you don't have Linux, you don't want to install softwares on your computer. You go on this web browser, on this web page, and you use it, and you can already do some analysis on your own. So this is the first use I see. The second one is for teaching, because with colleagues we discuss, I want for students to have the same softwares on different computers, so I need to talk to the IT to install it on different computers. That will be cumbersome and everything. So that is it's a solution for that. So if you have courses, workshop, or even hackathons, everything is settled. So you just have to give the address and you will get the tool ready. So, and if you want data on it, so let's just continue the demo. It's a live demo. Yes. So for example, if you want to install data on this toolbox, so here's a link. Okay, let's see if I go back to the chat. Can I see the chat somewhere? I'm stuck here. Can I do that? Yeah. Up, the link is here. So here's the command line. So to access if you want to do a copy and paste, it's a little bit complicated, but you do Control Alt Shift, and you have something where you can copy the command line I just give you. And normally it should appear here. Okay, let's get rid of that. So DataLad, I don't know how to say it properly, but DataLad is another tool. Maybe I will present it another Neuroccino. It's a way of managing data. So like that, you can access it, you can organize it. Here I'm accessing a repository of data, which is the Aomic dataset. It's something I'm used to it. It's an open access imaging dataset. And so the command I just give you it doesn't download the data, but give you the structure of the data. So if you do ILS, I will see the dataset is here. So it's organized in a bits format. So every subject's in each subject in a folder. So for example, if I go to this folder, copy, paste. So you have here anatomy, diffusion, functional. So if I go to anat, so the data are not already here. Okay, so I just need to do get data lab, get what is inside this folder. It will download it, and now I have access to it. So if I go to FSL again, so that was subjects 20, I should be able to load my data. Okay. 20. Yeah, it should work. And like that, you have access to the data. You can play with them, so you can process them. I think there is another way to move data to. I think I saw if you drag and drop, it should work too. Yeah, wow, live demo. So now that was on my personal computer, local computer, and I move it to the Neurodesk. And so I can also run it. So I need to get rid of this one, I think. And if I go to, yeah, and I can see my brain. That is cool. Okay, so I think, yeah, so that is the end of the tutorial I wanted to give you today. I think it's a great tool because you can have for students, for example, you can have access to, if you want to try your software, you don't know how to install it, you go there, you can play with it. If you don't like it, you don't install it on your local computer. If you like it, you can continue to work on it on this thing and so on. So I hope you will like it, like I like it, and I'm ready for some questions if you want it, or if you want to continue to play with it. I will let you do it.
Thank you. Super cool tool. Are there questions right now? People are gearing up. Right. Just for comprehension, it's basically like the terminals that give us access to the clusters that we all have at our universities, but centralized. Is that a way to think about it?
Here you don't have access to your cluster. You don't have access to your cluster of the cluster of your university. So if you want it to use it on your cluster, you need to ask the IT to install it. It's a container, so it should be really easy to install it. They made it easy to deploy on different platforms. So if you want them to give you access to it, it should be possible. Here,
the idea really is you have all the software tools and packages that we classically need to use in one spot.
Yeah, in one pocket. Yeah, everything is in it. So, and they try to update it frequently, so to have all the softwares updated. So yes, maybe they don't have. And again, it's a container. I think they give you access to the container. So if you want to put something in it that is specific to your use, you can implement it.
Cool. Hands are up. I think Lilith was first.
Yeah, thank you, Hervé. Super cool. I have two questions. So the first one, is there a memory limit or something?
So on the web browser, yes, I didn't check how much we have here. It's not say yes. You have. I'm surprised. You have,
140?
no, it's not that, but yeah, they say it's 140 gigabytes, which is not I don't think they give you access to this kind of memory, but I think it's a small, yes, maybe it's 2 GB, 2 GB of memory. And it's a small, so even for the hard disk, I think it's 20 GB. So you cannot put a lot of data in it. But if you install it locally or in your lab, you can have access to the memory of your lab. So,
Okay, thank you. And the second one is about like the privacy of the data. For example, let's say I'm collecting sensitive data, fMRI dataset, and then I'm putting it inside here. Is that okay?
It's a good question. It's a good question. I think, yeah, this data set, this computer is not accessible by everybody, I think. But yeah, if you have your own data sets and you want to use it, the best is to download the container and to use it locally, and not to use
So when I'm using locally, that
yeah, it should be
data
okay. It's a container on your
is not
local.
going anywhere.
Yeah. Here, what I am showing you is the web version, which is
Okay.
more open.
Okay, I understand. Thank you. Super cool.
Chris has questions, I guess.
Yeah, thank you for presenting that. It's really interesting, especially when you start analysis. I have two questions. One is what's the size of the Docker image? Because sometimes it can be very, very big, especially when you start using like machine learning things. Sometimes they have massive packages, but also like all the neuroimaging tools like ants. Ants is pretty big. FSL is pretty big. So if you
Yeah.
have everything packed in a Docker image, it must be pretty big, right?
Yes. So that is, yeah, it's a good question. I don't know if I can access. I don't know. I don't know the size exactly. I don't know if they talk about the size. What they say in the paper, they wanted to have a lightweight packaging. So I don't know. They managed to put everything in it, and
Yeah.
I don't know the size. I didn't check the size. I don't know. Yeah, like that. I'm not sure to find the size of the container. Let's see.
Yeah.
Wait.
Well, yeah, I mean, it can be a problem on some architectures, but still, it's a good idea to provide that. Another thing is, you said they update the image
Yeah.
regularly, but I guess you can just take their image and then modify it. I install things. I saw that on their Play thing. You can install packages, Python packages, for example.
Yeah.
So you could take their Docker image and then modify it to have everything you need for your analysis and keep it like that, and then share it.
Yeah, you can tune it. Yeah, you can tune it. For example, for courses you want to give to some students, you can implement your own softwares in it, and like that you have the full package. So still the question of the size of it, but you can modify.
And I'm guessing to share it, if you modify because if the goal is to also make reusable and shareable software, if you make your own in your own version of their Docker image, then you will want to share it. But I think you can do that. There is Docker Hub to do that, right? So that could be a good solution that you could develop your analysis and add some piece of software and then upload it to Docker Hub and attach it to your paper.
Yeah. It's true that other solution exists too, and they say that too, that other For example, there is also in the other world of the container, there is also Neurodebian, all the things that
Yeah.
are developed to have tools. This is that are available for neuroscientists. But the way they wanted to put it is to have something that is, yeah, everything is contained in this box, and maybe for advanced use, it's maybe not useful. But at least for when you want to start with students and stuff like that, you have something.
It seems more comprehensive than the other tools that you're talking about, like Neurodebian and stuff.
Yeah.
You can start with it, but you don't have many tools, and also it's pretty heavy, as I remember. I tried to use it a while ago, and it's pretty cumbersome to set up. So
And it's
I think
Debian.
that's a
So
step up.
yeah, and it's Debian.
Yeah.
So if you don't have a
Yeah.
Debian machine, you are stuck with other
Yeah.
solutions. So they wanted to have something very operable with different, so Windows, Mac, Unix, and everything. They want, yeah, they really did a good job to have something that works on any kind of machine.
And maybe the interest could be even bigger on cloud computing or supercomputers.
Yeah.
Because you could just install, you could just push this Docker image and use it as a base for all the analysis on the cluster, essentially.
Yeah. And at least you can reference it. Yeah, at least you have something that is stable, and this is the point. Yeah, in fact. Yeah.
Right. Any other questions that I missed? Not for now. In that case, thank you so much for presenting this software/paper. Super cool. And I wish you an exciting week in science. See you next Monday, and we also have a CNS talk next week, so do block that time, please. Have an exciting week. See ya.
See you.